go to point B, then I go to point C, then to point D. So my distance will be entire path that has been covered. That means I'll add this 5 meters plus 3 meters plus 5 meters. That will give me distance. And distance is a scalar quantities. All of you have done scalar and vector in your lower classes. Scalar quantities, they do not have direction. They just have their specific magnitude. So here also we'll be just discussing about the magnitude of it. And SI unit of distance is meters. Then comes the concept, one more concept you have, which is known as the concept of displacement. So displacement means, see, it's the same thing, going from A to B, B to C, C to D. Now, what is displacement? Means the shortest path that is possible. So it means whatever is the separation between the initial and final point, you call that as displacement. So if a person is covering this entire path, the shortest distance or the shortcut that is possible is by just joining A and D point. That gives the displacement. So entire was the distance, and the shortest path that we cover is displacement. These were the things that we had studied in the last class. Apart from this, one or two things we discussed, that distance, since it's a scalar quantity, and it comes when the body starts motion, when the body starts moving. So distance of a moving body is always increasing with time. So if someone asks you what is the graph between distance and time, it would be a straight line. How to calculate the slope? Slope will give you the velocity that we'll see afterwards when we'll be discussing velocity. Fine. So that is what is meant by distance. That is what is meant by displacement. And one more last thing, that distance is greater than displacement, or it can be equal to displacement. Because see, displacement is the shortest path and distance is the total path covered. So obviously distance will be more, but it can happen in certain cases where your distance and displacement both are equal. For example, we had seen the cases where, for example, if I give you this A and B, these are 2 points. Separation between AB is 120 meters. This is a straight line. So if my initial point is A, my final point is B, what is the distance covered? 120 meters. What is the shortest distance covered? That is also 120 meters. So distance and displacement can be equal, but distance has to be greater than. All right, these were the things which we have already seen in the last class. Now, certain questions, as I've told you in the last class, distance and displacement have no specific formula. Now we'll be practicing some questions from this part, from distance and displacement portion. Do one thing, just note down this first question. Just note down this first one. This is A, this is B, and this is C point. Note it down, I'll discuss it. First, note it down. A point, B point, and C point.
Done.
See class, if a body travels from A to B, now we have to calculate the distance, we have to calculate the displacement in both the cases. So just see A to B. When I talk about distance, distance means the entire path that has been covered. Means this blue line, entire is white, no? So this blue line shows this portion has been covered. Fine. This blue line, this part shows that this portion has been covered. Fine. So can anyone tell me what is this? How can I calculate? Say, let's say the radius of this is r. This portion, the radius is r. Can anyone tell me how much will this part be? Just this part.
Half of a semicircle.
Half of a semicircle. Very good, Martin. Exactly. See, we are just calculating the perimeter. If a body is moving, the body is starting from A point, then going to B point. So the body has actually covered the perimeter only, but not entirely. Body is going from A to B point. So that is half of a semicircle. Or what you can do, it's just 1/4 of a circle. You can write down in any way, half of a circle or 1/4 of a semicircle, 1/4 of a full circle. So see, in the first part, distance will be equal to 2 pi r. 2 pi r is what? 2 pi r is the entire circumference of the circle. But is it covering entire 2 pi r? No, it is covering only 1/4 of it. So this becomes 2 pi r divided by 4. So this becomes pi r by 2. That is the distance. Now second part says calculate the displacement. Now what is the technique to calculate the displacement? One method you use to calculate the displacement, that is directly join the initial and final point. Directly join. So initial point is A, final point is B. So I have to find out this. Now look class here. This radius is R, this radius is R. Can you notice one thing? Can we find out this part? What does it look like? This side is known, this side is known. Yes, Martin, can you try?
It looks like a right angle triangle.
Exactly, it is a right angle triangle. So it means we can use Pythagoras theorem, right? So we'll directly use Pythagoras theorem. This is R, this is R, right? So it's like, I'll draw the triangle separately also, those who are getting confused. This is the answer for the first part, for displacement. Look here. It's like this is your triangle, this is R, this is R, this is the unknown side, let's say X. So X square is equal to under root R square plus X square is equal to R square plus R square using your Pythagoras theorem. So X square becomes equal to 2R square, X becomes equal to root 2R. This is your displacement. Displacement is R root 2. Fine. Now, this is the first part for the points A to B. Next, it says A to C. Okay, A to C. Yes, answers in the chat column right now. This is the initial point A. This is the final point C. What should be the distance? Answer in the chat column. All of you should answer this part at least. A to C. This is very simple. We are going from A to C in distance and directly A to C in displacement. Abdullah, what you are answering is displacement directly from A to C. I am asking you distance. That means you have to cover the entire path. So now, see in the the way we did in the first part. Others also answer, only Abdullah is trying. What will be this part? See, we are starting from A point. We have started from A point. Now we have reached to C point. How much is the distance that we have covered? Yes, Afnan, Siddiqa, Sarah. Semicircle. Yes, Abdullah. It's a semicircle. Correct. Look here, class. When we talk about the distance, we cover the entire path. And when it is displacement, then directly join the initial and final point. So look here. 2 pi r by 2. Exactly. 2 pi r by 2. That means pi r. A perimeter of a semicircle. Good, Martin. So class, this is 2 pi r divided by 2. Semicircle. Semicircle has been covered in the second part. So second part, distance, this is 2 pi r divided by 2, which is pi r. And displacement is the easiest in this. Look, initial point is this. Abdullah has already answered this part as well. This is initial point, this is r. So radius is same, no, in a circle. It's not like at the top you have a certain distance and then at the edges it becomes thicker. No, entire circle has the same radius. So this part is also r class. So total displacement, that is this part, this becomes r plus r, which is 2r. Clear? This is how we find out. Okay, third part. Class, third part, at least distance and displacement, both you should be able to answer. It will hardly take seconds. From A to A, complete revolution. The person has started, or the body is traveling from A, covering this part, this part, this part, and landing back to A point. What is the distance that has been covered? How much distance has been covered? Should I call the names? Then you people will answer. Yes, Siddiqa. If you are traveling in a circle, 2 pi r. Good, Martin. It would be 2 pi r. Simply, it would be 2 pi r. Right? Why it would be 2 pi r? Because you are covering entire circle. If you are walking on the perimeter of a circle, then perimeter will be the distance covered. So answer is 2 pi r. So the answer for this part, the third part is. The third part, distance, is exactly entire circle has been covered. So this is 2 pi r. Now, displacement. Difference between initial and final position. Person has started from A point, coming back to A point. What should be the displacement? Shortest path. What is the separation between initial and final point? Yes, Afnan, you also try, Muhammad Afnan. See, if initial point is A, final point is A. What is the separation between the initial and final point? I think I've discussed this in the last class also. When your initial point and final point is same, what will be the displacement according to you?
0.
0. Very good, Martin. It would be 0. Good, Afnan. It would be 0. Right. Because your initial point is also that point A, your final point is also that point A. So it doesn't make sense. There isn't any displacement. There isn't the separation between initial and final point. So displacement is directly 0. All right. Last part, it is mentioning you the part E. Yes, Abdullah, it's okay. So A to E. All right. So E point is not given to you directly. Do one thing, otherwise it will become messy for you. Note down the answer for the 3 part. Then I'll mark you and give you E point. Otherwise, when I'll draw in this circle, no, it will become messy for you. You will not be able to figure it out. Draw this, write down the solution till the 3rd part. Then we'll discuss the 4th part separately. E point is given somewhere here, and angle is also mentioned. With that technique, just note down it till here. This is E point class. The fourth part, no, this is E point. And to solve this, you just need the angle over here, which is given to you as pi by 6. So pi, I hope you understand what is pi. When we write pi in the angle, pi means 180 degree. So for 90 degree, we'll write it as pi by 2. So if it is pi by 6, it means 180 divided by 6, that is 30 degree. So like this, it will be mentioned pi by 3, pi by 2, pi by 4. That means 180 divided by all these. Now, how to solve this part? I'll mark this and draw this separately. Look here. For the fourth part, this is the curved part. This is E part, the circular part. This is A point. This is the center O. Radius R is given and this angle is pi by 6. This is a little difficult part. So not very difficult. You will be able to understand step by step if you will see this portion. Now look here. In this, distance and displacement we have to find out. So for displacement, basic concept of angle and the length of an arc and radius of an arc and relation between of these will be used. See, initial point is A, final point is E. So we have to find the length of the arc, this part, right? This part for the calculation of distance. And this portion, A to E for displacement. Understood? Now see, there's a relation theta, that is the angle that is getting subtended at the center. It is equal to length of arc divided by the radius of arc. So length of arc will be equal to theta multiplied by radius of arc. Now length of arc will be, what is the angle given to you? Pi by 6. What is the radius? R. So the distance will be equal to L, which is equal to pi r by 6. Fine, this is the distance. So what have we actually calculated? We have actually calculated this part, this L, because this is will only be the distance that is covered. Now, when we talk about displacement, we directly join A to E. That means we are directly joining this part, A to E. This is unknown. Now see, this is an isosceles triangle. Isosceles triangle means where two sides are equal. So class, look, in this case, now we use a formula which is known as sine formula. I'll show you the formula. Because for isosceles, I don't know how many of you remember this formula. You must have done it in your lower classes. For isosceles triangle, no, the best method to calculate the other side, which is the unknown side, is through this only. Suppose this is ABC, this was the side R, this was the side R, this is unknown. So sine of A divided by the opposite side, that is BC, is equal to sine of B divided by the opposite side, AC, is equal to sine of C divided by AB. Angle, its opposite side. Then angle, its opposite side, angle, its opposite. All will be equal. So sine of A divided by BC is equal to sine of B divided by AC is equal to sine of C divided by AB. Now in the question which we were discussing, this pi by 6 angle B was given. R, AB and BC was given. What was unknown? AC was unknown, no? Only this AC was unknown. That was the displacement which we wanted to calculate. So just unknown is AC. But see, do we know sine A and sine C? Yes, of course, you can directly calculate this. How can you calculate? Look, this is 30 degrees. Pi by 6 means I've told you this is 30 degree. When we have isosceles triangle in class 10th only, you have studied this. In the properties of triangles, you have already studied this part, I think in 9th, 10th only, that for two opposite equal sides, the two opposite angles are also equal. So if these two sides are opposite, this angle and this angle, both of them will be same. So if you apply angle sum property, x plus 30 degrees is equal to 180 degree because of ASP, that is angle sum property of a triangle. What is angle sum property of a triangle? Angle sum property basically means all the three angles equal to 180 degree. So this means 2x is equal to 180 minus 30 degrees, that is 2x is equal to 150 degrees, x is equal to 75 degrees. Means this angle in the formula here, Sine A is 75 degree. Sine divided by BC, this is R. Sine B is pi by 6, 30 degree, divided by AC, which is unknown. Sine C is again sine 75 degree divided by A. No need to find the answer for this part because these types of questions will have such values which you will be able to solve it. Like sine 75 degree, you will not be able to solve it right now without the help of table, or only mathematics students will be able to solve it, right? So you will be having such values if just in case this part comes in your exam. Otherwise, usually the parts that are asked, no, until third part or maximum, this can be asked, the distance calculation, the length of the arc. So that is important because that is a part of your basics which you have studied. These types of questions are asked. Root sometime is used directly A to C. It could have been asked to you that this point, new point is D, then A to D, then 3/4 of a circle you would have taken. Like the simple questions are asked from the circular topic question, and especially students who have to appear for their entrances also after class 12. For you also, these types of questions are repeated. These are just the questions that come from this portion. But just in case if it has to take you to an extent, then this part maximum can be involved, where also such values will be given, where you have to, so only those value will be given to you where you will be able to directly solve it, like sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degrees, sine 0 degree, like these only values will be given to you will be able to answer. So just equate any two, find the unknown. Just equate these two, or just equate these two, find any two, equate any two with AC, this in between, you will be able to find AC, which is the displacement. But no need, again I'm saying, no need to solve this question at then, just know how to solve it just in case if it comes in your exam. Otherwise, these basic questions and including fourth part's distance, this part is also important. Till here, this is very much. But till here, you already have written, just make the changes in figure for the fourth part and note down the solution of fourth part. One more question I'll discuss with you regarding distance and displacement. Then we'll start with directly speed and velocity. We'll start with the next topic. Fine, just note down this one more question.
7.
See, the question is saying that a body travels from O to A. So this is in the form of semicircle, O to A. Then AB in the XZ plane, right? Then BC upwards, that is along y-axis. So see, if you see the distance, what is this part? This is, if the radius is A, then what will be this? Where the cursor is tracing, look here. What will be the distance just from O to A? We have discussed this in the above part. If the body is starting from O point, reaching to A point, radius of the semicircle is A, then what will be the perimeter covered, distance covered? You all don't know the perimeter of a semicircle. R pi plus 2, this is the semicircle's perimeter of the law, or the complete answer you're answering? No. The full circle's perimeter is 2 pi r. Semicircle is half of a circle. So 2 pi r divided by 2, that is pi r only. And what is the radius here? Here the radius is given as A. So from O to A, OA's distance I'm talking about. I'm just talking about distance currently. So O to A, this becomes pi A only. First tell me, is this clear or not? Why is it OA pi A? Clear or not? Yes or no? Sarah, Martin, Afnan. Right. So this is just a semicircle. So it is starting from O point, coming back to A point. So this is a semicircle. The distance covered will be pi A. Now, next is A to B. AB is already given to us, that is 2A. So AB is given to us, that is 2A. Then from B, it is going to C, which is given to us as 3. It is mentioned separately also. This is given to us as 3A. So BC is given to us 3. So what will be the total distance? Total distance will be pi A plus 2A plus 3A, which is pi A plus 5A. What we can do, we can take A common. What will be left? Pi plus 5 meter. This is the total distance. Coming to displacement. See, displacement means from O to C if you directly join. Right. But see, this is difficult because no angle is mentioned to us. No side is mentioned to us. We don't even know the proper axis for this. What you can do, just for all these terms, write down the displacement for individual. See, directly if you write from O to C, you'll never be able to get your answer because nothing is mentioned. So what you do, the way we wrote individual distances and we added it up at the end, OA, AB, BC. Similarly, write down the individual displacements. Then add it and find out the total displacement. But one thing that you have to remember, distance was a scalar quantity. So we directly wrote it. Displacement is a vector quantity. You have to keep in the sign. So can anyone now tell me from O to A, what will be the displacement?
Pi A.
How much, Martin?
Pi A. Pi.
Pi A is this part. See, this part is pi A, the semicircles part. Is this the displacement? So yes, Martin, what will be the displacement?
A.
See, this is your O point, this is your A point. This part is A, radius, this part is A. So, 2A. 2R. Yes, Abdullah, 2R. Or here the radius is given as A. We discussed this, no? It means you have not understood the last part. Here, when it was going from A to C, half of a semicircle, directly R plus R, that gave you the displacement 2R. Whereas it was entirely pi R. So pi A is the distance, 2A is the displacement. So here as well, displacement. So from O to A, this becomes 2A. Now, where towards which axis? It is along x-axis. And see, I'm again repeating x, y, z. You have 3 coordinates, unit vectors. We have done this. We'll again do this in detail. Do not worry about this part, which I'm going to discuss, because in your vectors specifically, you have this part. For x-axis, you use the symbol I cap. For y-axis, to depict something is along y-axis, you use the symbol J along with this cap, J cap. And for z-axis, you use K cap. We'll be learning this in detail, I cap, J cap, K cap, after this lesson, before starting with the next lesson. So do not worry about this. Just right now understand. So this will be 2A I cap. Now, when we are putting the unit vectors, no, I cap, J cap, K cap, that is showing you that we are mentioning the direction also. So magnitude along with direction, that gives you a complete vector quantity. Displacement is a vector quantity. Distance was scalar, so we could directly add it. Add it up. Displacement is vector, so we have to keep in mind the directions concept. Then coming back to AB, from A to B, this is given again as 2A, but along y-axis, z-axis. This is given along z-axis, so K cap. And then BC, it went from z-axis to y-axis. Remember, look here. From BC, it is going along y-axis. So y-axis, we use the unit vector J cap. So BC becomes 3A J cap. So what will be the total displacement? This is going to be 2A I cap plus 2A K cap plus 3A J cap meters. Now, how to solve this further, this we'll see later on. But this is just, in this, you should just understand the concept of distance and displacement. Note down the solution, then we'll start with speed and velocities portion.
Done.
Coming to the next topic, that is speed and velocity. Now, the basic topic was your distance and displacement, as I've mentioned in the last class also. Now, this will keep on building up. In the sense, you have speed and you have distance and displacement. All the concepts building block of speed is basically your distance, and building block of velocity is displacement. So your distance and displacement will contribute to speed and velocity. Then further, the speed and velocity, this will contribute to your acceleration. Like this will keep on building up. So what is speed? I'll first talk about speed, because then understanding velocity is easier, because velocity is just a vector quantity. Speed is a scalar quantity. This is the major difference between them, and rest of the differences are because of this portion. Otherwise, they are physically the same. So what is meant by speed? Whatever is the distance that is changing with respect to time. For example, if I say 5 meters per second, this means in 1 second, 5 meters is covered. Then in next second, again 5 meters will be covered. Then in the third second, again more 5 meters will be covered. Like this. This is what is meant by speed. So speed, this is mainly distance, and do not use displacement, because speed is a scalar quantity, distance is a scalar quantity. So speed is distance divided by time, a very basic formula. Class, tell me one thing. If I write time as 1 second, if I write time as 1 second, what will be the relation between speed and distance? Can anyone tell me by looking in this at this formula? If time is 1, then what will be left in the formula? What will be the relation between speed and distance? Yes, Sarah. Sarah, look at this formula. Speed is equal to distance by time. If I write time as 1 second, what will be the relation left now? If the denominator becomes 1? No idea, Sarah?
Time is equals to distance, speed by distance.
See, time is equal to speed by distance. That is correct. See, anyone else? Just distance. It means good, Abdullah. See, all of you, others also listen. If time becomes 1 second in the formula, what is left? Speed will be equal to distance divided by 1. What is distance divided by 1? This is distance only. Means if your denominator, that is time, becomes 1 second, all of your speed will be equal to distance, right? So speed is equal to distance. So how can you define speed? Speed is the distance covered in 1 second. This is how you can remember. Speed is the distance covered, right? They are equal. Speed is the distance covered in 1 second. Fine. So speed is equal to distance by time. It means for a particular time, let's say initially this is 5 meters, then 2 meters is covered, then 1 meter is covered, then again 5 meters is covered. Here, let's say the time is 1 second remaining only. So this part, 5 by 1 second, that will give me its speed. 2 by 1, distance to time 1. So 2 by 1 gives me speed. This gives me the speed. Like this, we have the speeds. So it's a scalar quantity, rate of change of distance, we say. And see, whenever I use the term rate, rate means when something is changing with respect to time. Anywhere in physics, if you have this concept, this means the same. Anything that gets changed with respect to time, we call it as rate. Rate of change of distance, rate of change of displacement, rate of change of velocity, rate of change of speed, rate of change of anything you can add if anything is getting divided by time or anything is getting changed with respect to time. So it's a scalar quantity, it is rate of change of distance. SI unit, when we were discussing dimensional analysis, when the first lesson when we were discussing dimensional analysis, that time also we had seen this. that the see SI unit is very easy to mark. Distance SI unit is meter and times SI unit is second. So distance divided by time means meter divided by second, meter per second, right? This is meter per second. And CGS unit also I have discussed with you that the CGS unit of distance is centimeters. So centimeter per second, but maximum time you will use the SI unit meter per second. Class, remember one test you gave? I think Martin has given the test. Martin, Harsha, and one more student, Ruhina. Right, Siddika, you have given. 3 students have given the test. So you had seen a question where you could get your answer where 1 kilometer per hour had to be converted into meter per second. So if you people remember, all of you were able to answer this correctly. You all got 5 by 18 meter per second. So if anywhere it is required where your velocity, where your speed is given in kilometers per hour, directly multiply it by 5 by 18 and get your answer is in meter per second, because standard SI unit, this is the SI unit is the standard unit. Everything has to be converted into this form and then the final answer has to be obtained. Fine. Now, speed is also not of a single type. You have uniform speed, you have non-uniform speed. And further in non-uniform also you have instantaneous and average. So we'll discuss each of these. Method to solve uniform is very easy, direct algebra. But in uniform, when we discuss instantaneous, there you will be requiring a little bit knowledge of your calculus. That's why we did integration and differentiation prior to this lesson. And all those who are weak in calculus, they are not able to differentiate properly, not able to integrate properly. Please keep on practicing, because now from now onwards, you will be having till your class 12's last lesson, you will be having questions where differentiation and integration will be involved. So wherever doubts you have, let me know. See the playlist wherever you get stuck, whichever question, let me know. Arrange a class for yourself, get your doubts cleared. So types of speed are 2 types: uniform, non-uniform. I'll discuss each of these. Or let me discuss uniform speed first. See, uniform speed basically means when the body is covering equal distance in equal interval of time. Fine. For example, this is the distance A, B. I want to move from A to B. I have covered 5 meters in 2 seconds. Then again, I am covering 5 meters in 2 seconds. Again, I am covering 5 meters in this 2 seconds. Again, I am covering 5 meters in 2 seconds. Again, I am covering 5 meters in 2 seconds. 5 meters in 2 seconds. So do you see what is the distance covered? I'm just talking about this small part. Let's say AO. What is the distance covered? 5. What is the time taken? 2. So 5 by 2 meter per second. Distance by time, that becomes the velocity. This part I took. Let's say this is D. I'm taking one more random part, DB. What is the distance? 5. What is the time? 2. 5 by 2 meter per second. Again, I'm getting. Now take any of the portion. You will get 5 by 2 meter per second only. Right? 5 by 2 meter per second will be your answer. That is 2.5 meter per second is the velocity. So what has happened? Equal interval of in equal intervals of time, equal amount of distance was covered. That is simply known as uniform speed. Fine. You just take, and how to find the answer for uniform speed? Just take the distance, divide by time. Take the distance, divide by time. For the entire duration, take the total distance, divide by total time. But mainly for uniform speed, just take the distance divided by time. By putting everything into the formula, you will get your answer. Coming to non-uniform. See, in non-uniform, you have 2 types. So before starting with non-uniform, just note down till here, because non-uniform, you have 2 types. So I'll discuss the types. From here, note it down first. Now class, last is non-uniform speed. So when the speed is variable, means suppose here I am covering 5 meters in 2 seconds, but in the next moment I am covering 6 meters in 2 seconds. And then again I am covering 5 meters in, let's say, 3 seconds. So this is non-uniform. Distance is also not equal. Time is also not equal. So if the body is covering unequal distances in equal interval of times, or equal distances in unequal interval of times, mean 5, 6, 5, 6, 8, 9, any meters divided by 2 meters, like this. So that is known as non-uniform speed. Any of the variable changes that speed becomes non-uniform from uniform. Now you have the concept of average speed. Instantaneous we'll discuss later, I think in the next class only, because some of you can at least revise differentiation and come, then only you'll be able to understand instantaneous. But see what is meant by average speed. One single formula for average speed you have. Average speed basically means total distance, not only distance. In uniform speed we were having distance. It is total distance covered by total time. For example, look here, question 1. Let me discuss question 1 with you. A to C from between via B. So A to C via B. S1, this part is 10 meters, time is 10 seconds. This part is 20 meters, time is 5 seconds. What was the formula which I have just discussed for average speed? Total distance divided by total time. Good, Abdullah. Total distance divided by total time. So what is the total distance? Here we are having 10 meters, here we are having 20 meters. So 10 plus 20. And what about the time? Here we are having 10 seconds, here we are having 5 seconds. So 10 plus 5. So this becomes 30 divided by 15, which is 2 meters per second. 2 meter per second. That is how we write. Right? So 2 meter per second is not the velocity. This is the average velocity. Simple method. One more question. Let me discuss question 2 also with you. Okay, this is given. Velocity is given as 10 meter per second. Here, velocity 2 is given as 20 meters per second. And what is the average speed? See, now it is asking you the average speed. So what is the total distance covered? What is the total time taken? Look here. In this case, I don't know what's the distance, right? V1 is the speed and T1 is 3 seconds. So distance is equal to speed multiplied by time. So distance 1 will be speed multiplied by time is 30, right? Again, distance 2 will be speed multiplied by time, that is 20 into 2. This is 40 meters. Now we have the distance. Can we calculate the speed? See, in any ways you have to find out the distance. I had the velocities already. I could have just taken their mean value, 10 plus 20 divided by 2, but that is not possible because time is not constant. In one you have 3 seconds, and another you have 2 seconds, right? So initially we have 30 meters. Secondly, we have 40 meters. Now you have the distance. How did I get the distance? I had the data for velocity and time, and I multiplied the speed and time, and I got the distance. So once I have the distance, what is the formula? Total distance. Total distance is 30 plus 40. What is the total time? 3 plus 2. So this becomes 70 by 5. So that is 14 meter per second. This is the average velocity. This is how you calculate average velocity. Even if distance is not mentioned, you find out the distance, then solve, because the formula remains same. Average velocity is total distance by total time. So this was the first concept. In average, you have very good questions also from this part. I'll discuss the questions. Note down this. Please text done in the chat column once you have written till here. All right, class, just wait for 5